Welcome back to the Deep Dive. Today, we're tackling something really fundamental if you're a senior Java dev or aiming to be one, especially for interviews. We're diving into the java.lang class,
Yep.
and, runtime type information, RTTI.
Yep. Absolutely core stuff.
And our mission today is not just listing features. We want to take the technical details and really shape them so you feel genuinely confident discussing this in an interview. Like you can talk about class objects, reflection, dynamic stuff, almost like you wrote it yourself.
That's the goal, because the class, it's more than just another class. It represents the types themselves, right, when your code is running. It's really the gateway to reflection, lets you look inside classes, interfaces, even methods at runtime. It's how a lot of frameworks do their magic.
Right. So we'll break down, what is a class object? How do you get one? And we'll navigate the naming conventions, which can be tricky. Definitely an interview gotcha there.
Oh.
How to compare them, load resources using them, and how it all sets you up for reflection. We'll flag those key ideas and, importantly, the common mistakes interviewers look out for.
Okay, so let's unpack it. What is a class object? Think of it like the blueprint, the meta information about a type, but available during runtime. It's an actual object, an instance of java.lang class. And the fascinating part, it's not just for the objects you create from your classes. It represents, pretty much all types.
I mean, not just like my customer class or string. It represents things that aren't even traditional objects.
Exactly. Yeah, it covers regular classes, sure, but also interfaces, enums, records, annotation interfaces, even primitive types like int or boolean and void.
Wait, int, seriously, like int.class?
Yep, int.class. And critically, every single array type, doesn't matter the dimension or the element type, each one gets its own unique class object. So stringarray.class is different from intarray.class, which is different from int.doubleArray.class. They each have a specific class instance.
Huh. And the JVM just makes these.
The JVM handles it all. As types get loaded, it automatically creates the corresponding class object. There's no public constructor. You can't just say new class. It's managed internally.
Okay, that makes sense.
All right.
I notice in the docs you see class with the question mark wildcard all over the place. What's that about?
Class with wildcard? Good question. That's mainly about type safety when you're dealing with reflection or situations where you have a class object, but you don't know its specific type at compile time. It basically tells the compiler, hey, this is a class object for some type. I just can't tell you which one right now. It helps avoid raw type warnings and keeps things cleaner when the type is truly dynamic.
Got it. So if we know what they are, the big interview question is probably, how do you get one?
Yeah.
Seems like there are a few ways.
3 main ways. And yeah, interviewers definitely expect you to know these and, crucially, when to use each. First, if you have an object instance already, say my object, you just call getClass on it. So myObject.getClass. Simple, gives you the class for its actual runtime type.
Okay, straightforward enough.
Second, if you know the type name when you're writing the code, at compile time. This is usually the best way. Cleaner, preferred. Use the .class literal, like java.util.scanner.class, or stringarray.class, runnable.class, int.class, even void.class. It's type safe, no string lookups involved.
Right, compile time knowledge means .class.
Exactly. Third way is for dynamic situations. When the class name only exists as a string at runtime, maybe you read it from a config file or user input. That's where the static method Class.forName comes in. You pass it the string, like Class.forName with string_java.util.scanner.
Okay, perfect setup for a scenario. Let's say I'm building, a plugin system. Users specify the class name in a config file. How do I load that class using just the string?
That's the textbook case for Class.forName. You don't know the name when compiling, right? You only get it when you read the file at runtime. So you take that string name and pass it to Class.forName.
And the flip side, when is .class clearly better?
Whenever you know the type right there in your source code. If you can type scanner.class, do it. It's direct, it's type checked by the compiler, and importantly, it doesn't throw a checked exception you have to deal with.
Exceptions. That's the big catch with forName, isn't it?
Huge catch. And honestly, forgetting this is a common interview mistake, a real red flag. Class.forName throws ClassNotFoundException. It's a checked exception, part of reflective operation exception. So if you use forName, you have to handle it. Either add a throws clause to your method or, more likely, use a try-catch block. It's non-negotiable.
Okay, mandatory error handling, good reminder. Okay, let's shift gears. Naming. This one tripped me up initially. You've got getName, getCanonicalName, getSimpleName, getTypeName.
Yeah.
They sound similar, but especially for arrays, They can be weird.
Oh, they absolutely can be. You're right. It's a classic interview gotcha area. Let's break them down. GetName. This gives you the binary name. It's what the JVM uses internally. For a normal class like string, it's java.lang.string. Fine. But for arrays, it gets weird. Stringarray.class.getName returns open bracket L java.lang.string semicolon.
Bracket L semicolon, okay?
Yeah. And for primitive arrays like int array, it's open bracket I. Multiple dimensions, just stack up the brackets. A 7D int array, that's open bracket 7 times than I.
Whoa. Okay, definitely not user-friendly.
Not at all. It's the internal representation. For primitives themselves, it just returns int, boolean, etc., and void for void.
So what about getCanonicalName then? Is that better?
Usually, yes. If you want something readable that follows Java language rules, getCanonicalName would return java.lang.stringarray or int array. Much nicer. But, and there's a key but, getCanonicalName can return null. It does this for things like local classes, anonymous classes, or arrays of types that don't have a canonical name. So you need to check for null.
Oh, okay. So potentially null, but generally more readable. What about getSimpleName?
GetSimpleName is just the name as you wrote it in the source code, stripping the package. So string scanner. For arrays, it takes the component simple name and adds brackets. String array, it gives an empty string for anonymous classes, though.
And getTypeName.
That's a bit newer, often similar to getCanonicalName, maybe slightly more informative in some edge cases. Oh, and there's toString, which adds class or interface before getName, and to generic string, which gives you everything, modifiers, type parameters. Very verbose.
Okay, so if the interviewer asks about getName versus getCanonicalName for arrays, the key is that binary L or I notation for getName versus the more readable int array style from getCanonicalName. But remembering getCanonicalName might be null. Exactly.
Nail those points, maybe give the L example, and mention the null possibility for getCanonicalName. That shows you understand the nuances.
And the anti-pattern is clearly using getName, thinking it's a nice display name.
Spot on. If you need something for logs or UI, getCanonicalName with a null check. Or getSimpleName is usually what you want, not getName.
Right. Okay, what about comparing class objects? Can I just use double equals? My usual instinct for objects is dot equals, but class feels special.
It is special in this regard. And yes, you can and should use double equals because the JVM guarantees there's only ever one class object instance loaded for any given type within a class loader. So if you have two class variables, C1 and C2, checking C1 double equals C2 is checking if they refer to the exact same unique object instance. It's a reliable reference equality check.
So if my object.getClass double equals employee.class, that works perfectly.
Perfectly. It directly checks if my object is precisely an instance of the employee class. No need for dot equals is the way.
Okay, so interview question.
Yeah.
Can you use double equals to compare class objects? Answer, yes, because the JVM ensures only one instance per type per class loader.
Concise and correct. That's what they want to hear.
Let's switch to a practical use case. Resource loading. Config files, images, things packaged with the code. How does the class object help there?
Super common, super useful. The main method is getResourceAsStream with string name. It returns an input stream for reading the resource. The absolute key is understanding how the name path works.
The path resolution. Hit me.
Okay. If the name string starts with a /, it's treated as an absolute path from the root of the class path or module path. Find it from the very top level. If it does not start with a /, it's treated as a relative path relative to the package of the class whose getResourceAsStream method you call.
Relative to the package.
Okay. There's also getResource with string name, which gives you a URL object. Less common for just reading data nowadays, but useful if you need the URL itself. And a big plus. This works seamlessly even if your classes and resources are bundled up inside a JAR file. The methods know how to look inside the JAR.
Okay, let's try a scenario. I've got config.properties. It's in the com.myapp.utils package right next to my configloader.java file. How do I load it from configloader?
Since it's in the same package, you use a relative path, no leading slash. So inside configloader, you'd call configloader.class.getResourceAsStream with string config.properties.
Makes sense. Now, what if I move config.properties to the very root of my JAR file, outside any packages?
Then you must use the absolute path. You need that leading slash, so it becomes configloader.class.getResourceAsStream with string/config.properties.
Got it. The anti-pattern is definitely mixing up relative versus absolute, especially forgetting that leading slash means root.
Absolutely. That leading slash changes everything. Forgetting it is a common bug when refactoring or structuring projects.
Beyond loading things, class objects also tell us about hierarchy, right? Superclasses, interfaces.
Yeah, you can navigate the type tree. GetSuperClass gives you the class object for the direct parent class. It only returns null for object itself, interfaces, primitives, and void. And getInterfaces gives you an array, a class array of the interfaces that this class directly implements or that this interface directly extends.
So if I had like class myComponent implements serializable runnable, then myComponent.class.getInterfaces would give me an array with the class objects for serializable and runnable.
Exactly those two. Not interfaces implemented by the superclass, only the ones declared right there. And there are generic versions too. Get generic superclass and get generic interfaces if you care about type parameters like list string. And then there's checking relationships. The methods isAssignableFrom and isInstance. These sometimes cause confusion.
Yeah, I can see that. What's the clearest way to explain the difference? Maybe that container mold analogy.
That works pretty well, I think. Let's try it. This class dot is assignable from with other class. This compares two types. Think of this class as a variable type, like a container shape. Think of other class as a blueprint or a mold. The question is, can the mold, other class, produce something that will fit into the container, this class? It returns true if other class is the same as or a subclass of or implements this class. It's asking about assignment compatibility between the types themselves.
Okay, isAssignableFrom is type-to-type compatibility. What about isInstance?
This class dot is instance with objector. This involves an actual object. Object. Think of this class again as the container shape and object as a specific item you already have. The question is, does this specific item object fit into the container of this class? It returns true if object is an instance of this class or any of its subtypes. It's basically the dynamic equivalent of the instance of operator.
Ah, okay. Container mold for isAssignableFrom. Type check. Container item for isInstance. Object check. That clarifies it.
Yeah, hopefully that helps distinguish them. The anti-pattern, getting the order wrong in isAssignableFrom. Remember, A dot is assignable from with B asks if B can be assigned to A.
Got it. Class objects can also tell you what kind of thing they represent, right? Like, is it a primitive, an array, an enum?
Yep, a whole bunch of Boolean is methods, is primitive, is array, is interface, is enum, is record, is annotation. Also things like is sealed, is synthetic compiler-generated stuff, is anonymous class, is local class, is member class, and so on.
Useful for branching logic based on the type.
Exactly. And if this array is true, you can then call getComponentType to find out what it's an array of. If this record is true, you can call getRecordComponents. If isSealed is true, getPermitted subclasses.
And the anti-pattern here.
Calling something like getRecordComponents before checking is record. You got to check the type first, then call the specific methods for that type. Otherwise, you risk exceptions. Don't assume.
Right. Now, the big one for many. Reflection itself. Peeking inside classes. Fields, methods, constructors. What's the absolute key distinction here?
The number one thing to get right is the difference between the getMethods and the getDeclaredMethods. Huge source of confusion and interview questions. GetFields, getMethods, getConstructors. These return public members only. And crucially, they include inherited public members from superclasses and interfaces. GetMethods, for instance, will give you public methods from object 2.
Okay, get means public and inherited.
Right. Now, getDeclared fields, getDeclaredMethods, getDeclaredConstructors. These return all members public, protected, default, package private, and private, but only those declared directly within this specific class or interface. They do not include inherited members.
Ah, so getDeclared means all access levels, but only in this specific file, not inherited.
Exactly. If you want to find a private field defined in my class, you must use getDeclaredField. GetField won't find it because it's not public.
What about modifiers like public, static, final, get modifiers? Just gives back an int.
Yeah, it's a bit mask, an integer where different bits represent different modifiers. The anti-pattern is trying to decode that integer yourself using bitwise math. Don't do it. Use the static helper methods in java.ling.reflect.modifier, like modifier.isPublic with mods, modifier.isStatic with mods, modifier.isFinal with mods, where mods is the integer you got from getModifiers. It's readable, reliable.
Oh, okay. Use the modifier class helpers.
Definitely. There's also modifier.toString with mods, which gives you a nice string like public static final. And newer Java versions have access flags, returning a set, which is maybe a bit more modern.
So quick check. Got a method object, M. Need to know if it's public and abstract.
Get the modifiers. Int mods, m.getModifiers. Then check. Modifier.isPublic with mods, modifier.isAbstract with mods. Both helpers must return true.
Simple enough using the helpers. One last area. Nested classes, inner classes.
Class helps there too. If you have a class object for a member class, a non-static inner class, getDeclaredClass tells you the outer class it's defined in. For local or anonymous classes, defined inside methods, getEnclosingClass gives the immediate class they're inside. You can even find the specific method or constructor they live in using getEnclosingMethod or getEnclosingConstructor, useful for frameworks analyzing code structure.
Wow, okay. That covers a lot of ground. That was definitely a deep dive. I feel like we've hit the really crucial parts of class and RTTI, especially focusing on those interview angles and common slip-ups.
Absolutely. It really is foundational. Getting a class object, knowing the naming quirks, navigating the hierarchy, and especially the get versus get declared distinction for reflection mastering these is a big part of senior level Java understanding.
And folks, remember those anti-patterns we flagged? Forgetting Class.not-found-exception for ForName, mixing up getName and getCanonicalName, especially for arrays.
Right.
Getting the wrong in getResourceAsStream.
Classic mistake.
Trying to decode get modifiers, bits by hand.
Please don't.
Avoiding these really shows you know your stuff.
The best way to cement this, try it out. Seriously. Grab class objects for different things, an enum, a record, an anonymous inner class, in array, and just call these methods. See what they return. Experiment.
Good advice. Well, if you found this deep dive useful, please do hit that like button and subscribe so you don't miss future ones. Let us know in the comments what other Java interview topics you'd like us to tackle next.
Yeah, we'd love to hear from you.
And here's a final thought to chew on. Think about frameworks you use every day. Spring, maybe Junit, Jackson for JSON parsing. They lean heavily on reflection and the class behind the scenes. How does knowing the mechanics, the capabilities, and maybe even the potential pitfalls we discussed today change how you think about how those powerful tools actually work? Something to ponder.
Good question.
Thanks for diving deep with us. We'll catch you on the next one.